So in this video we're going to look at question 16 up to 21, or the start of 21. So just make a little bit over to the right. A rectangular piece of plastic has 6 circular holes, each of radius r. So you can see here there's going to be an r here, an r here. So there's 6 of them all the way across. There's going to be 4 of them going up that way. So we have 4r and we have 6r. And we're asked to find, in terms of r, the width, well we've done that, 6r, and the length 4r, and the area after the 6 circular holes have been removed. Well, the area of the whole thing, we have 4r by 6r, which is 24r squared. And the area of each circle, so one individual circle on its own, is pi r squared. So we have 6 pi r squareds. And we know pi is a number, so we have 6 by 3.14 r squareds, which is 6 3s 18 and 6 14s is 84, so 18.84 r squared. So 24 minus your 18 is going to leave 19.516 r squared. So that's what will be left for part C. And D, hence express the area of the piece of plastic with the holes removed as a percentage of the area of the rectangle. So that's just our 5.16 that we already have. Well, it could be r squared if you wanted. We don't need the r squared here, over 24. So 5.16 over 24 times 100 works out to be evenly 21.5%. That's question 16. Question 17, the rectangle and square shown have the same area. So find the area of the rectangle. So we have 5 minus root 7 by 5 plus root 7, which is going to be 5 5s 25, plus 5 root 7 minus 5 root 7. They're going to cancel, and we have minus root 7 by 7 by root 7, which is minus 7. So 18 is it units here, cm, 18 cm squared. Find the length of one side of the square. So the length of the square, well, for the area of the square to be 18 x times x squared is equal to 18. So x has to be square root 18, which your calculator will do for you, but as surds it's root 9 by root 2, which is 3 root 2s, and you're asked for it in surd form. So make sure when you're answering these questions to just draw a quick sketch of a rectangle and a square into your copies, because you won't be able to revise from it if it's just numbers with no question given. So here we're going to draw this in a rectangle, side, or one length 10, and the width is x. Find the perimeter of the rectangle, just add to it. We have a 10 and we have an x, so the perimeter is 10 plus 10, 20, plus 2x for part A. 20 plus 2x. The value of the area of the rectangle, well, the area of the rectangle is going to be 10 times x, which is 10x. The value of the area of the rectangle is equal to twice the length of its perimeter. So the area is equal to twice the length of the perimeter, so twice the perimeter, which we got in the first part. Now the book's answer is 2.5, which eliminates this 2 from proceedings, but it is, the way it's asked is twice the perimeter that we've already gotten. So 10x is equal to 40 plus 4x, so 6x is equal to 40. So x is equal to 40 over 6, which is equal to 20 over 3, which is equal to 6 and 2/3. If you eliminate the 2, you get 10x is equal to 20 plus 2x. So you get 8x is equal to 20, x is equal to 20 over 8, which is 2.5, which is the answer in the book. But from what they've given us, this to me seems to be the answer. Okay, let's look at, they're kind of awkward that this part here is not part B. So a rectangle has sides of length P and Q. Okay, we're going to do a sketch here. A rectangle P and Q. And P is greater than 4. The value of the area of the rectangle, so PQ, so it looks like it's setting up the previous part, is equal to twice the length of its perimeter. Twice the perimeter is twice Q, 2P plus 2Q. So that's what we have set up here. So it looks like the book's answer is wrong for that part. So what do we ask here? The value of the area is equal to twice the length of the perimeter. Use the above information to write Q in terms of P. Right, we need to isolate Q. PQ is equal to 4P plus 4Q. So 4P is equal to PQ minus 4Q. We can isolate Q here by saying 4P is equal to Q times P minus 4. So 4P divided by P minus 4 is equal to Q, and the reason they're saying P is greater than 4 is that this can't be equal to 0 here. It wouldn't be possible. So that's where the 4 comes into it. So that's question 18. Let's go over here and look at 19. Right angle triangle DEF is given in the diagram here. And we have a 7A on the bottom. So just take that out and move it over here. What are they trying to get us to do here? 7A. The area of the square is 74A squared. So the area of the square is 74A squared. Each side is the square root of 74A. Because if we multiply that by itself, we get, and that A is outside the square root symbol. Just move it inside, just prominently outside. So find in terms of A, DE and then DF. So DE, well, DE we have, it's the square root, this is DE here, the diagonal, D to E, and we have F. So the square root of 74 times A is DE, and DF, well, DF we're going to have to multiply it out, so we're going to have, I'll do it the long way, 7A squared plus X to be squared is equal to the square root of 74A squared, which is the area of the square. So we have 49A squared plus X squared is equal to 74A squared. So X squared is equal to 25A squared. So X is the square root of that, which is 5A. Then we're told the area of DEF is 100.8. Find the value of A. I'll do it up here. So the area of DEF, which is the triangle, so half the base by the height, half the base of 7A by the height of 5A. Half the base by the height is equal to 100.8. So we can say here that 35A is equal to 201.6, so 201.6. So A is equal to 201.6 divided by 35, which gives, don't forget your squared, 35A squared. So A squared, A is equal to the square root of that. So A is square root of 201.6 over 35. Which gives 2.4 centimeters, 2.4 cm for A. Now, 20, the length of the square. So the area of the circle inscribed is 81 pi in here. So we can say pi r squared is equal to 81 pi. So we can divide by pi to get r squared is equal to 81. So the radius is 9. But we're not asked that, so let's see what we are asked. Right, as a fraction in terms of pi, the area of the circle over the area of the square. Well, if we have the radius is 9, we have now the length of the square has to be 18 by 18. So the area and it's in terms of pi. So the area of the circle is 81 pi, and the area of the square is 18 squared. And you should be able to see that that works out to be pi over 4. 18 is 9 by 2 by 9 by 2. So the 9s will divide into the 81, leaving 2 by 2 on the bottom. So pi over 4 is the answer here. And to the nearest percent, how much bigger is the area of the square than the area of the circle? Okay, square 18 squared is 324 for the square, and the circle is 81 by 3.14, which gives 254 34. So the difference between them is 69.66 is the difference between the areas. And if we divide that by the area of the circle, we get it in terms of the area of the circle times 100. That gives 27.38%. We round it off to 27. And if we do the difference in relation to the area of the square, that gives us 21.5%. So we're not sure which one to write, do both. And then find to the nearest centimeter, question 21 here, the side length of a square that is inscribed in a circle of diameter 50. Okay, well, there's the diameter of the circle, which is 2 radiuses. So that's going to be my right angle triangle with a 50. And this is a square, so they're the same length. So we can say that x squared plus x squared is equal to 50 squared, 2x squared, 2500, x squared, 1250, and the square root of 1250 is 35.35. So what are we looking for here? To the nearest centimeter, so 35, nearest centimeter, 35 centimeters. So in the next video, there's a bit more of this question asked. So continue with question 21 in video 5.